Good afternoon to all. A warm welcome to the third session of our block STTP on blockchain applications. In this session, we are talking about an introduction of Hyperledger Fabric, which is handled by Mr. Santosh K. Thomas, project manager in IBM India Private Limited. I find immense pleasure in introducing our speaker, Mr. Santosh K. Thomas, who had been working as a project manager in IBM India Private Limited. He holds BA degree in Electronics and Communication from Bapuji Institute of Engineering and Technology. He has more than 70 years of experience, starting from various stages of software design to software project management. He's a kingpin in industry. And prior to IBM, he shows his talent in various industries as principal applications engineer in Oracle, a software engineer in Birlasoft. He's an expert in various technologies and holding a patent on event-driven audit logging. He achieved different kinds of certifications in different levels. Among that, I would like to point out Data Science Foundations Level 2, IBM Blockchain Consulting, Blockchain Architecture Design and Use Cases. In the course, the Blockchain Architecture Design and Use Cases, he secured a 4th rank, which is organized by IIT Kharagpur. His outbox of the thinking and innovative problem-solving abilities are highly appreciated by former Indian President late Dr. APJ Abdul Kalam when he presented an idea on the process improvement for Indian Railways. Moreover, he has a visionary leadership with a can-do attitude, strong technical skills, articulate communicator with strong analytical and interpersonal skills, known for honest ethics and delivering projects in time without compromising on quality. It gives me immense pleasure to extend a very warm welcome to Mr. Santosh K. Thomas to deliver a talk on introduction of Hyperledger Fabric. Thank you. Welcome, sir.
Thank you very much, Sijo, sir, for the beautiful introduction. Okay, yeah, it's an immense pleasure to talk to you about Hyperledger Fabric. I am currently working in the Hyperledger Fabric area of IBM blockchain. So I am into IBM for past 10 years, and I have been doing this project management for the 10 years. The whole IBM career was project management, and recently, I changed my project, and I am right now working the.
Excuse me, sir.
Yeah.
Can you share your screen?
Yeah, sure. PowerPoint share. Yeah. And currently, I am working in the IBM blockchain garage, where we do blockchain related work. So let me get into our training now, the discussion meeting here. Anyway, all of you have been hearing about blockchain for quite some time and for past few days. So I think almost everybody should be well aware of what blockchain is. That makes my life easy, and I can concentrate more on the Hyperledger Fabric area. So let me start. Mm, okay. Yeah. So for the brief introduction, like let's touch up with the what is public blockchain, private blockchain. The blockchain is divided into two mainly. One is a public blockchain, and the other one is a private or permission blockchain. The public blockchain, when we hear about public blockchain, the first thing which comes into the mind is the Bitcoin or the cryptocurrencies. But and even like okay, some people who are already into the blockchain area, yeah, Ethereum also, and many other things will come into their mind. And when we go to the private blockchain, we will be discussing about Hyperledger Fabric, and there are other blockchains like okay, Quorum and Corda and all. There are many more right now. There is no hybrid blockchain. The thing is like the implementation of private plus public together in an ecosystem, we can call it as a hybrid. So today we will be concentrating more on the Hyperledger Fabric. And to talk about what exactly is a blockchain, blockchain is somewhat like a replica of all the business concepts. If you think what exactly, like if you try to think a business, okay, every business need to have a business network. Yeah, blockchain is also having a business network. To do a business, we need to have participants. Blockchain needs participants. To do a business, we handle assets. Okay, yeah, blockchain also handles assets. In a business, we sell, we buy, and that is called a transaction. And in blockchain, we record the transaction. The thing is, in a business, we keep some well, while doing business with big companies, or like okay, when companies do business with companies, or we do some, we actually give a work for building a house also, like okay, we enter into a contract. So blockchain also have contracts. And in every company, for every business, what we do is we record the transaction on a ledger. And yes, blockchain also holds a ledger. So you all know what all these things are because you have been going through these things for quite a few time, some time now. So what is the main objective of blockchain? The thing is, with the blockchain, we actually implement the blockchain in an untrusted a business. We can tell it in that way, where blockchain can bring trust in that business. How it will bring the trust? Okay, one is the consensus. So you people would have discussed about proof of work, proof of stake, and all those things. Many consensus are there right now. The consensus is that okay, like coming to an agreement with all the participants in the network. That is consensus. The another property of the blockchain is immutability. That means we have recorded something, we cannot reverse it back. It's immutable. Finality means like it's a single place of truth where you can go and find what is the truth. Provenance. If provenance means like okay, if I buy a land, okay, if that is a transaction which I am doing on an asset called land, if I want to know who all were owning that land earlier, that means the history of all the transaction of all the owners. So that particular thing, if you can go and find out what was happening behind this asset, that particular thing is a provenance. We can prove things. So that is these are the four properties, main properties of blockchain. Now what I want to do is like okay, as you all are from different industries and backgrounds, or like okay, what I want you people to do is like I want you people to think in the way like, okay, in a scenario where you can understand blockchain or hyperledger fabric in a better way. Because most of the time when we discuss about blockchain, we will be discussing about uh, companies doing business with each other. Now here I am putting a hypothetical scenario in front of you all, where our state government tries to implement hyperledger fabric blockchain. We all know how our state government works. Okay, we all know how which all departments are there and what a department do and how actually every department works. So you can imagine, even if this can be taken as a homework for you people all, like, okay, you can go start thinking how it would be if I try to implement a blockchain network for the state. So can how much down, deep down to the network I can go, or how much up can I go? So those things, like, okay, will help you to understand more and more the complexity of blockchain. So I'm just leaving it to you all. Here what I am going to do is I'm going to give a very peripheral idea about this use case. It's a hypothetical use case. Now let's think in the blockchain way. What are the advantages of implementing this use case? The thing is, like, okay, seamless process movement. Yeah, from department to department. They don't have to have interconnectivity. They can work independently and get networked using a blockchain. And from one department to another department, they can things can move seamlessly through blockchain. That is one case. Okay. Another, control and exposure of corruption. The thing is, like, it is not that, okay, corruption, we will be able to stop corruption. Corruption is actually a mentality. The thing is, if somebody knows that, okay, whatever he does, he's putting his fingerprint over there, and that is being recorded. Naturally, that will stop corruption. That will actually, it will expose corruption, which will help to reduce the corruption. And when the corruption reduces, naturally, we all will be having more and more trust towards the ecosystem. And after all, when all these things are in the blockchain readily available, and you can, if you have the permission to go and view the things, that means it's all permission based. Okay, it's not that everybody can go and view it, because it's a permission based blockchain. In a public blockchain, yeah, you can go and view it, but in a permission based blockchain, um, uh, if you have the enough rights to view the things, we can always, like, cater to the Right to Information Act. Okay, now let's, as we are hosting it from Kerala, I have just taken the Kerala example. Here, if we think that, if we are trying to implement Hyperledger Fabric blockchain in Kerala, then we need to have a business network. How the business network would be? The business network would be from the topmost district to the bottommost district, which is Kasaragod to Thiruvananthapuram. This will be the business network. Okay, that business network will include every district. That means all the 14 districts will be the part of the business network. Okay, in that case, so all the 14 districts will be the participants. And for each district, for each participant, there will be an identity. So here we are covering these topics. The business network is here. We have the participants, and each participant is having an identity. And now going to the asset transaction and ledger assets. Imagine if I am selling a land. The land is an asset. When I am selling that land, that becomes a transaction. And contracts is something like, okay, if I am selling a land, I should be selling it to a person whom the India government allows. Okay, there may be some countries we may not be able to sell to some people which the government may not allow, or there are some other rules that a person should be adult, he should not be a minor, he should not be a person of 3 or 4 years old. So those things, all those business rules, those things are like captured in the contract. Okay. And finally, all these transactions are getting recorded on a ledger. Okay. So now for our hypothetical situations, we will, like scenario use case, we will just imagine we are trying to onboard 3 departments. One is PWD, the other one is water, the other one is revenue. And now going into asset, what exactly is asset? There are 2 types of assets. One is a tangible asset, the other one is an intangible one. The tangible assets, like okay, are like home, whatever is tangible, car, house, land, everything tangible. Intangible one, like okay, it's like a mortgage or like digital music. All those things are intangible, or patents, or are intangible assets. And even cash is also an asset. So now we are going to discuss about assets and all those things. So just to make you understand what exactly is asset. Now we will consider a problem. Actually, like if you think this is not a very complex problem, this is a this is a problem which we are trying to solve with the blockchain. In a current scenario, if there is no blockchain, if there is no concept of blockchain, how exactly uh, we are trying to, okay, if a participant A wants to transfer 1 lakh rupees to participant B. So there are 6 participants in this network. Imagine this is a business network, a regular business network, and A is there, B is there, bank is there, auditor is there, regulator is there, and insurer is there. So A is transferring 1 lakh rupees to B. So when he transfers the 1 lakh rupees to B, he informs to B, he informs to insurer, also he informs to the regulator, auditor, and the bank record. So they trust that, okay, A is going to say that, okay, whatever he has transferred to B, he will be communicating to others. That means A transferred to B, and A is going to communicate to all of them that, okay, he has transferred 1 lakh rupees. Imagine the case A transfers 1 lakh and he tells that he has already transferred 10 lakh rupees to all others, other 4 participants. How will you validate that in the current scenario? In the current scenario, the auditor has to go to the A's location, or like, okay, auditor has to view the records of A, auditor has to view the records of B and make sure that, okay, yeah, what A is saying is correct or not. So in that case, like, okay, when A says that, okay, he has transferred 10 lakh rupees, auditor will see that, okay, A has recorded 10 lakh rupees, but B has received only 1 lakh rupees. So that is not a valid transaction. So this particular method, that, like, okay, there is a lot of problems. It's ineffective, expensive, vulnerable. And how we can resolve this is, there is a solution. The solution is a centralized database. But there are problems for this solution also. If you say that we can we solve it with a centralized database? Yes, we can. We can surely solve this with a centralized database. But why? What is the problem here? The problem was regarding the trust on A. A transferred 1 lakh and he told 10 lakhs. And imagine A is the person who is owning the centralized database. He can always go and change it. So the thing is, it's a matter of trust which is keeping away from centralized database, plus the maintainability. There are many other problems for centralized database. Right now, we have a solution for this one through blockchain. So as you know, blockchain is a decentralized database ledger. It's a ledger, decentralized ledger, which every member or every peer in this particular network will have, and all the copies of the ledger, all the ledgers will be in sync. That means whatever data is there in A, the same clone of that ledger will be there in B. It will be there, the same clone in bank also. So all the people, all the members in this network will be having the same database. So with that particular thing, we can actually achieve the consensus, provenance, immunity, and immutability and finality. How blockchain solves this problem? The thing is, even though everybody owns a ledger, they will not be able to write or read or delete. It's not like read. They will not be able to write or update or delete on their ledger directly. They will have to do it only through the blockchain network. So if A is saying that he has transferred 1 lakh rupees, he has to push that transaction to the blockchain network, and the blockchain network will update all the ledger. That is the responsibility of the blockchain network. So blockchain network will make sure that all the ledgers are in sync. And there are different technologies for blockchain. And we are now going to talk only about Hyperledger now. So this is the anatomy of blockchain, but okay, I have this picture is from Hyperledger Fabric only. So this is not the same structure for all the blockchain. Now we'll be talking only about Hyperledger Fabric. You know that blockchain is a chain of blocks. So B0, this is the genesis block, B1, B2, B3. Now what happens is, what does B0 holds is, okay, what does a block hold? A block holds a header, data, where the transactions, and a metadata. This is in case of Hyperledger Fabric, this wave thing that represents a ledger. Okay, and the ledger holds the block chain of blocks, and the block holds header, data, the transaction, and the metadata. So what does block 1 hold? B1 holds the hash of the B0 header and Merkle root of the data of all the transaction and the signatures and all those things, and it will be again hashed and put it in the header. It can have a single transaction or it can have multiple transactions. A block can have a number of transactions. The transaction can be limited through a configuration, but okay, we are not going to discuss about those things. Configuration and all we are not discussing in this particular session. We are just thinking about the concepts. And hash in block 2 will contain the hash of block 1 plus the Merkle root of D2, D2, the transactions in D2. And what does a block metadata contain? The block metadata contain the public key, the signatures, and the timestamp. Okay, there is one more flag which will the block data contains, that is whether the transaction is valid or not valid. Okay, we will come to that particular thing later. Okay, that is the speciality of Hyperledger Fabric. So that's why I told that this metadata part is different for Hyperledger Fabric. Now, what is Hyperledger Fabric? Okay, it's a one like okay, blockchain technology for business under the Linux Foundation. Okay, here the ledgers are there, the smart contracts are implemented as chain codes. Chain code, what is the difference between a smart contract and chain code? The thing is, in a practical scenario, usually a chain code will contain only one smart contract. Okay, chain code is the name which we call for smart contract in Hyperledger Fabric, but there is some additional features to it. The thing is, imagine we are doing imagine a company who has got presence in US and India. In US, they will be doing the transactions in dollars, and in India, they will be doing the transactions in rupees. Most of their business rules are same across the company. Okay, imagine in that way. So we can have a smart contract for handling dollar related activities, and we can have a smart contract for handling rupee related activities where the business logic remains the same. Okay, so chain code will hold both the smart contracts, both the dollar version and the rupee version of the smart contract. Okay, but in a practical scenario, most of the time what I have seen till now is like, okay, usually a chain code will have hold one smart contract. Okay, this is the high information about uh, fabric. The current version is 2.1. That is the live. And IBM is one of the contributors for Hyperledger Fabric. So let's now try to differentiate between a public blockchain and a permissioned blockchain or a business blockchain. So if you think about a public blockchain, uh, let's just think about Bitcoin. So how can you do a transaction in Bitcoin? The only thing what you have to do is you have to install a Bitcoin wallet. Somebody XYZ person has to transfer you some Bitcoins. You can go and purchase it, or else like, okay, you can get those Bitcoin as a transaction also for some other goods sold. Okay, so once the Bitcoin reaches your wallet, okay, then naturally you are part of this particular blockchain. Okay, so for joining that blockchain, you didn't take any permission or nobody authenticated you specially, or like nobody checked whether you have the rights to join this particular network. So that's a public blockchain. Anybody can join. If you have your public key, private keys, yeah, you can join with that particular public key, private keys to that network. If that network allows, that's public blockchain. So in a permission blockchain, like okay, Hyperledger Fabric or Quorum or Coda, you the person will be able to join only the network agrees to adding that person, that it is permissioned. You cannot come and join a blockchain created by IBM for a business purpose just like that. If you have a wallet, you cannot come and join. So that is the difference between the permissioned and a public blockchain. So here in the case of Hyperledger Fabric, uh, the member identities are known. Everybody in every permission blockchain, the member identities are known, and they will be having a role-based access. Okay, and transaction confidentiality. Okay, in the case of Bitcoin, if somebody has transferred Bitcoins to me, naturally the whole world can see, all the people who are there in the Bitcoin blockchain can see the transaction, and they can see that, okay, 1 Bitcoin is transferred to me. But you cannot know, you will never know that who transferred that Bitcoin to whom. You can only see that 1 Bitcoin is transferred in this transaction from an X person to a Y person. So here the members or the participants are anonymous. But in case of permission blockchain, for the example which we took, like, okay, if our state government is going to implement the blockchain, if I am from Pathanamthitta district here in Kerala, so if Pathanamthitta district is inserting a transaction to the network, blockchain network of Kerala, then it should be known that, okay, this particular transaction has come from this person or from this district. So here the members are all known. Whoever does the transaction, it is known that, okay, a member like this X person or this district or Kottayam district did a transaction. So that is one of the key difference between a public and a permission blockchain. Now going to the cryptocurrency. In the public blockchain, the consensus is most of the time achieved with proof of work. So for doing proof of work, there are miners, and those miners do the mining because they get incentives as in the form of cryptocurrency. So in case of Bitcoin, they get Bitcoins. But in case of, and like that is the thing which actually encourages them to go and do the mining. But in case of permission blockchain, where everybody is known, all the members are known, they are doing the transaction for a, like, a provenance, finality, immutability, all those features. In a business, one member is doing a transaction with another member through blockchain to create a trusted environment. That is like, okay, in a non-trusted business, they have implemented blockchain to bring in trust. So there, they don't need any incentive. They are doing it for their own benefit. That means both the parties are getting benefited there. So there is no incentives there, and it is most of the time it is not proof of, or not, it's not like most of the time you don't need to use proof of work. You can use different types of consensus algorithms. And another thing is, if you take public blockchain Bitcoin, we cannot go and change the program. We cannot customize the program for our need. But in permission blockchain, we can customize the program for our need. The business need of a healthcare industry may not be the business need of a financial industry. So both will be having entirely different scenarios. It will be entirely different from a telecommunication industry. So each industry can have, or you can have a number of blockchains, a number of private blockchains, and each blockchain can be customized based on the business requirement, and that is achieved through the smart contracts or else the chain code. So this is the main 4 requirement which you should be very clear why we need to have a permission blockchain. Why can't we do these things with a public blockchain, or like something like Ethereum? Most of you would have uh, gone through Ethereum and all. I believe you would have gone through Ethereum. Ethereum is a public blockchain. And when you start building Ethereum, you build a test network, or you start building the, if you're trying to build a new program or DApp or anything, you start building it on your computer, and you will be building a network there in your computer. That itself is a private network. That means with the Ethereum tool, GoEth, you can build a private network, but the thing is, you will have to use proof of work or proof of authority related consensus. But there are other problems which that particular network, that private network will not be able to solve, which we are trying to solve with this permissioned blockchain. Okay, so try doing some R&D on Ethereum also. Like then you will understand why. What is the actual need of um, a permission blockchain? What it cannot do and what this can do. So let's discuss about nodes. Nodes are there in all the blockchains. That's a common term used in blockchain. So in public blockchains, there can be, all the nodes are same, and some will be having more computational power and they will be called as miners. But in case of Hyperledger Fabric, each permission blockchain has got a different structure. Okay, and the people who are like, okay, if yeah, I will not go into that particular area because there are many permission blockchains, and like each has got different architecture. So as we are going to discuss only Hyperledger Fabric, we will talk in the terms of Hyperledger Fabric. In Hyperledger Fabrics, all nodes are not same. Okay, so we told that, okay, there are members, there are different members, that each district is a member. So we can consider this as a secretariat, and this can be each district. Okay, and each district can host nodes. So let's consider these are nodes. They can host multiple nodes, or they can host a single node. So why multiple nodes and why single node, that we can discuss later. We'll be talking about that one later. And each node will be assigned with the identity, and it is provided by certificate authority. Okay, the certificate authority provides the certificates, and MSP holds the certificates. Okay, let's go further. Now let's go to the Fabric ledger. So now we are discussing, now we have started discussing mainly about the Fabric architecture, the components in Fabrics. The first one is the nodes, and the second one, ledger. So Hyperledger Fabric ledger is a bit different from the regular public blockchain ledger. When we talk about Hyperledger Fabric, when we tell about ledger in a Hyperledger Fabric, this ledger is divided into two. One is a transaction log, the other one is a world state. So this W shows, like, represents the world state, and this is the transaction log. This transaction log is very similar to the regular blockchain, which the blockchain world, which we call, where it holds the block, the transaction log holds the block and chain of blocks, and the chain of blocks will be having the transactions. Then what exactly is the world state? World state holds the current state of the asset. There can be a number of assets. The world state holds the current state, the latest state of the asset. So in case if you want to know what is the most of the time in the business scenario, we will be always handling with the current state of the asset. So that we can directly get it from the world state. And in the transaction log, all the history will be there. Let's take the example of this particular car 0123. So here in this case, let's take car 3. Car 3 is owned by Max. It's a Volkswagen and it is owned by Max. Now imagine if I purchase that car, okay, the owner will be changed from Max to Santosh. So the world state of this car will have the value only Santosh. That means it will have this particular data, the topmost data. It will hold the car 3, it will hold the color, it will hold the make and owner Santosh. The same way that is true for all other assets. If you see, each row is an asset here. Car 0 is an asset, car 1 is an asset, 2 is an asset, and 3 is an asset. And what will the transaction log have? Transaction log will have Max and transaction log will have my entry also. The transaction, the latest transaction where the world state got updated, that transaction block will be there in the transaction log and world state will hold my name. This world state in Hyperledger Fabric, the default world state comes as like level DB. We have an option to change it to CouchDB. Why CouchDB is like, okay, it can handle complex queries, rich queries. So if you have a rich query requirement where you have to query multiple things deep, then okay, yeah, you can go for a CouchDB, or else you can use a default level DB. So let's go through what is like written over here. Ledger is used to manage the state of asset. Ledger contains transaction blocks and world state. One ledger per channel. Channel we will be discussing later. Okay, just understand one ledger per channel. And transaction read-write sets are written to the blockchain. Channel configuration are also written to the blockchain. The world state can be either level DB or CouchDB, level DB or CouchDB. So transaction configurations with the channel configurations, okay, there is that is a little more deeper into the architecture. Actually, there is something called a system channel other than a regular business channel. We will discuss that one when we discuss channel. Okay, the types of nodes. Okay, there are the primary thing, the main node which we are going to discuss over here is the orderer node. As the name specifies, orderer node orders the transaction. That means, imagine if we take the case of the Kerala blockchain, what happens here is like there are 14 districts, and in case of like, okay, Pathanamthitta districts, there are 9. There is one district block panchayat, there is a collectorate, there is a around 9 block panchayats and around 55 grama panchayats. So imagine if there are transactions coming to this particular blockchain from all these entities. What the orderer will do, it serializes the transactions, it orders the transactions, and once after it reaches the requirement of creating a block or cutting a block, that means we can mention different parameters. One of the parameters is that the block can contain this many transactions, n number of transactions, or else the block size should be of this much, like, okay, 2 MB or 3 MB, like that. So whatever criteria is matched, which is first matched, okay, based on that, the orderer will create the block. The next one is a peer node. So peer node is the node which all the end users will be having. No, it's not the end users will be having, means like, okay, peer node is a node to which all the end users will be interacting. Okay, we should say in that way actually. Um, that means if we consider the Kerala blockchain, that scenario itself, every district should have at least one peer node. Okay, every district should have one peer node. There can be multiple peer nodes. Imagine Trivandrum being the capital. There can be multiple peer nodes which can handle different tasks. Okay, so what is a specialty of a peer node? Peer node holds a copy of the ledger, and inside the peer node itself there are different types of peer nodes. There are like committing peer nodes and endorsing peer nodes. By default, all are all the nodes are committing nodes. In a network, in a Hyperledger Fabric network, every node which participates in the Hyperledger Fabric ecosystem will be a committing node. But we will be elevating the rights of a few nodes. That elevation of the right is to execute a business logic through smart contract. They are called the endorsing peers. That means the peers which has got more power, a special permission is called endorsing peers. And the specialty of endorsing peer is that they will be the one who will be executing the smart contracts. Every peer in the network will not execute the smart contract in case of Hyperledger Fabric. Okay. Then there are different types of peers: anchor peer, leader peer. Okay. Anchor peer is the peer which um, uh, like okay, other organizations um, like okay, recognizes. That means imagine there are two organizations. Imagine even our neighboring state Tamil Nadu is also hosting um, uh, like network like this, and we are having a very big network across India that is called network of networks. Okay, so the thing is that communication between Kerala and the Tamil Nadu will be, we can consider that the chief minister's office peers will be communicating to each other. The anchor peer is a peer where other organization organized in this organization. There are multiple anchor peers, but there should be at least one. Leader peers are the peers which receives the blocks from the orderer. Okay. Now this is the diagram for that one. There's an orderer. Orderer cuts the block. It sends to the leader peer. Leader peer will give it to anchor peer, and it will share distribute it to the other peers. That's a simple way of representing this. The client node acts behalf of the end users. We can consider that client node as a mobile application. We can, that is a client. Okay, the client interacts with the network through some SDKs and APIs. Okay, and clients can be written on Java, Node.js, Go, and all. Now, getting into deeper into the components, ordering service. Okay, as we told, what exactly is orderer? Okay, this is a representation of orderer in a Hyperledger Fabric. Okay, by default, for the development purpose, Hyperledger Fabric comes with a solo ordering service. Solo ordering service is like there will be one node for ordering. There will be only one node for ordering. That is a solo. That will do the functionality of the orderer. It will collect all the transaction, it will sequence, and it will cut the block and send to the peers back. But that is not suitable for production, because if that node goes down and the whole entire network, the entire network will go down. So for the production, there are two different types of configuration, that is called Kafka and Raft. So ordering services can be, that means Kafka will be having multiple ordering nodes, and Raft also will be having multiple ordering nodes. Now going to the Fabric peer. Okay, so this is represented as a peer. Okay, and this is represented, this below one are represented as a ledger. This A and B are the smart contracts or chain code, and this local MSP is the one which holds the certificates for this particular peer. Now in this diagram we can, and these are channels we'll be talking later. Next we'll be talking channels. So channels, you just understand that channels is a means of communication. Okay, so peers. Okay, so right now here, if you say that there is a peer, there are two chain codes, and you can see that there are multiple ledgers. That means a peer can hold more than one ledger. And what is the scenario for that one? We will be telling that here in the channel. So what exactly is a channel? Channel is limiting your communication between a set of people. Imagine there are 10 members in this particular network. We can have a public channel between all the 10 members. That means whatever published to that particular channel, whatever transaction pushed to that particular channel will be received by all the 10 members. Okay. And added to that, like, okay, we can even have a separate channel, or not only one, many separate channels between limited number of participants. That is like, if I want to have a separate channel between 4 members, I can have. I need to have a separate channel between 5 members. I can have. So what happens, whatever you push into the channel of 4 members, whatever transaction you put into the channel of 4 members, that transaction will not be visible to all the 10 members present in the other channel. Imagine, what I can say is, let us consider in our Kerala blockchain scenario, let us consider that each department can be considered as a channel. So PWD can a channel, electricity can be a channel, water, irrigation can be a channel. So whatever happens, like, okay, health department will be having, imagine health is also a channel. Health department will be having a set of members. Those members may not be required in the electricity board channel, but they all are part of the same business network. They are part of the business network. All these things get, like, okay, like probably chief minister's office or secretariat will be part of all the channels. So there can be different channels. So the thing is, why we have to use a channel is, imagine whatever we put into a channel, it should not go to the other channel. To explain it clearly, but okay, I will tell you a scenario here. Let's consider the difference between a public channel and a private channel. Imagine both some nodes from each department is part of the public channel. So PWD is a part of the public channel. Water authority is also part of the public channel. One of the node is part of the public channel. So what happens is, like, okay, we have most of the time we have seen that, okay, soon after we tar a road, within 1 or 2 months, the PWD, the water authority may come and dig the road for putting a pipe. So why that happens is because all the funds for the road tarring and even for putting the pipeline is approved from a central authority. So all these projects, the PW had submitted a project and water authority also had submitted a project. Both the projects gets approved almost at the same time when they approve the projects. So what happened, the PWD comes, put the tar, and by that time water authority will go and buy some pipes and come back, and when they start the work, like a PWD would have already completed the tarring, and that will actually, they will have to break the tar, break the road, like dig the road. So if this is in the blockchain, what happens? So now it is October, like, okay, so now if PWD, if the projects for PWD is approved for November and the water authority's project is approved for December, then naturally when you insert a transaction of approval of these two, when the water authority transaction comes into the blockchain, it will find that, okay, there should be a business rule to identify that whether there is a PWD work going on before this, road tarring is going on before this. So yeah, there is a transaction happening in the, which is approved for November. So that case, the transaction of water authority will fail because the business scenario fails here. We have told that, okay, we should not tar immediately, we should not dig the road immediately after the tarring of the road. So again, they will have to prioritize that water authority work before the PWD tarring. And there are, so that is a public blockchain, not public, but the public channel concept. Now, when coming to the private channel concept, why exactly PWD will be having a separate channel, health department will be having a separate channel. Now, COVID is going on. Somebody is publishing the data of some patients in the health department channel. Okay, they identified a number of COVID positive today. They are pushing the data. That may not be relevant for the PWD department. So why should PWD get that particular transaction? So that transaction is limited, totally limited in the health department channel. But it is still, it is under the state government. So it is under the state business network. So that is the concept of the channel. So for each channel, there is a ledger. That is the concept of hyperledger fabric. So health department will be having a ledger. Water authority will be having a ledger. Electricity will be, or PWD will be having a ledger. So that's why you can see multiple ledgers mentioned here. A peer can have multiple ledger if a peer joins multiple channels. You can see this particular scenario. Here, you can see that this particular district, it has got only one peer. So this peer has to join all the relevant channels. This peer will be joining the PWD channel, the health channel, the water authority channel, but that peer will not club all the data, it will be having separate ledger for each channel. But imagine this is a secretariat and there are a lot of transactions coming up, and in that case, what they can host multiple peers for each channel. So that's why we can see 3 different peers over there. So going further, so you can see E0, E1, these are peers. This E0 is having 2 channels, E1 is having 1 channel, and there's the order. And chain codes are actually installed on peers. Okay, that chain code programs are installed on peers, but it is instantiated on a channel. That means the logical version of a chain code will be in the channel, that is instantiation. So that means whenever you install a chain code, okay, you have to instantiate. Whenever install a new chain code, you will have to instantiate the chain code. And instantiation is done based on the channel. Now PWD water and revenue. Okay, so let's go to the client application. Now client application can be written in Go, Node.js, Java, and it interacts through the Hyperledger Fabric SDK. Now the Fabric CA is the one which it's a certification authority. Certification authority, you know that okay, provides the certificates. And why Fabric CA? Fabric CA is the one which can work very closely with the Hyperledger Fabric network. It is designed to work in the Hyperledger Fabric network, but Hyperledger Fabric network Fabric has got the feature that okay, it can incorporate any certification authority. Imagine Maruti Suzuki is building a network over India, and it is inviting Hyundai. So what Hyundai may be having their own certificate authority. So they may be telling that I know I am using Symantec, okay, where Suzuki is using Fabric CA. No problem. That Hyundai can join the organization with their own certificate authority. Okay, so that particular flexibility is there. In the development environment, we use certificate cryptogen tool to generate the certificates. Right now, okay, you can see in our upcoming demo, I will be showing how to use that one. So let's get into the core thing of Hyperledger Fabric. Now this, how exactly it is. This is a network. And this is we have discussed almost everything, all the components over here. So we will just go through how exactly the Hyperledger Fabric works. Client SDK submits a transaction. Okay, so these are the components of the Hyperledger Fabric. There's client SDK, this is the orderer, this is the peer, and the peer has got 2 types of peer. One is endorsing peer, the other one is a committing peer. There's a ledger, there's a chain code, and it will be transmitting events. And there is a membership service provider, there is a Fabric CA and all. Now, the difference between Hyperledger Fabric is that, okay, it does the endorsement, ordering, and validation. So that we will be understanding in the next session. Here, this is the Fabric network. This is the client application. These are the endorsers. These are the peers. Actually, we have 5 peers here: E0, E1, E2, P3, and P4. So you may be wondering why it is E0, E1, E2. Because it is, these 3 are the endorsing peers. These 3 will be able to execute the smart contract or the business logic. So the client application sends the transactions to the endorsing peer, and this thing is defined in the endorsement policy. Now, next thing is the endorsing peer will be executing the transactions, and they will execute the smart contracts, and they will validate the business rule and see whether the transaction is like okay, following all the business rules or not. then it will provide the read write sets. Okay, it provides the read write sets to the endorser back and to the peer back, and the endorsing peer communicates back to the client application with a proposal response. And after this, the client collects all the responses from all the endorsing peers. Then it clubs, it bundles all the responses to the endorsing peer, and it will communicate to the ordering service. That in our Kerala blockchain, what happens is from all the peers, from all the districts, from all the block panchayats, gram panchayats, will be getting the transactions, and all the transactions will be getting ordered in the orderer, and then the orderer cut the block, orders the transaction, and then the orderer cut the block. So after order to cut the blocks, okay, it will send to all the peers, E0, E1, E2, P3, and P4. So here we are considering all these are leader peers, and from this P4, it can communicate furthermore to other peers also. And the sixth step, when all the peers have received the block, they will validate the block. They will validate the block means they will check whether the read write set of the blocks is valid with the current world state. So that is the validation part which is happening at every peer once after receiving the block. And this block will be stored after the validation. This block will be added to the ledger, this local ledger, after the validation is through. So when you do the validation, you initially, like earlier I told that in the blocks, when in the Hyperledger Fabric blocks, in the metadata, we have another option to a flag to set whether a transaction is valid or not valid. That particular flag is getting set over here. Finally, when all the peers receive the block, they emit events, and we can do many things after receiving. There are many events in Hyperledger Fabric, and we can configure events in the peer level, smart contract level. There are a lot of flexibility in the Hyperledger Fabric in that. So these are the 7 things mainly which is happening in the Hyperledger Fabric. It's the way how the transaction happens in the Hyperledger Fabric. Just I will summarize once again. The client submits the transaction to the endorsing peers E0, E1, E2, and the endorsing peers executes the transactions against the smart contracts, and the smart contracts returns that results to a read write set, and the read write set is sent back to the client, and the client sends that read write set to the orderer, and the orderer receive all the read writes, all the transactions from all other nodes, and it cuts the block when the criteria for block cutting is met, and it transmits the block to each peer. Each peer means every committing peer. And once the block reaches the committing peer, the block gets validated at the peer, and once the validation passes, it will be added to the blockchain. So this is mainly the way how Hyperledger Fabric works. So yeah, any questions? Oh, sorry, I think the screen sharing stopped. So Jubilant, sir?
Hello?
Yeah. Hello? Hello?
Tell me, sir. Hello? Can you?
Yeah.
Hello?
Any questions? Any questions? That's what I'm asking the participants. Do you have any questions?
Dear participants, if you have any doubts, please you can ask now.
Sir, may I ask one question?
Yeah, sure.
Yes, okay.
Yeah, so myself Sheetal from PICT Pune, Maharashtra.
Yeah, sure.
So, sir, that was very nice session. I just wanted to ask one question based on the slide where you have shown me shown the types of the different nodes of the
Uh,
electric
different types of
nodes.
nodes.
And
Nodes. This one, right?
uh, yes, exactly. Yes, sir, yes. So, yeah, I guess previous to this. So uh,
This is blockchain requirement nodes.
yeah.
Yeah,
So,
you can come to your question.
yes, sir. So the question is like, you said there are some nodes dedicated for who will be executing the proof of stake or say smart contract. Sorry, smart contract. I mean,
Correct.
and not all of the member nodes will be executing the smart contract.
Correct.
So, what can be the parameters or characteristic of the individual nodes which we can identify or analyze or say observe to designate them as a particular node to be able to just execute the code of the smart contract?
Okay, let's consider a trade. Okay, I'm doing a trade from this country to another country. So the thing is, when I sent one consignment from here, okay, the customs or the port should validate whether it is transferring or transporting the thing
Yes,
which they are allowed to,
yes.
right? So the port can be a peer which can execute the smart contract. Okay, but the
Yes.
thing is, if a transport authority, like, okay, imagine VRL in India, okay, they may not be interested what is getting transferred. Okay, they don't have to, they can be a peer here, but they don't have to execute a smart contract. So like that, for each scenario, it's a scenario based.
Okay, okay, okay.
So the thing is, that's our business requirement will decide who needs to run the smart contract and make sure that, okay, this particular transaction is meeting the business requirement. So how exactly we define that one? I told that, okay, it is done on using endorsement policies. The endorsement policies are defined when you instantiate a smart contract in Hyperledger Fabric. Okay, that means you install it and then you instantiate it for a channel, and the channel has got 10 members, and you want 3 members of the channel to three member organization or 3 peers. That means we will be telling that, okay, this peer for each organization need to validate. Means that when we instantiate the smart contract, we will be defining that, okay, when you execute this smart contract, you need a positive endorsement from these 3 peers. So
But
when we install, in the case what I told now for the transport, okay, if we are telling that, okay, it has to be validated by India port, and imagine if it is going to Malaysia and Malaysian port, we can make those two as the endorsers, and also the person who submits the transaction. That means, imagine it is a business between 2 big companies. Even those 2 companies also need to agree that, okay, I am transferring this stuff and you are going to receive this stuff. This is as per our business agreement. So they both also can be endorsers, and even both the port also can be endorsers there.
Yeah, this can be the, yes. I got it, sir. But the question is still there, that how it is managed in the Hyperledger. So as you said, it's literally based on the application which you are going to implement it in, and based on the application requirement, will endorse the node, and then they'll be able to do the execution of the smart contract, right? But
Yeah, it is mainly based on the application requirement. Let me just
okay, application
transaction for
requirement.
the just order sense. Yeah, it is mainly based on the application. It is not based on the power of the machine, because imagine if you
Yes,
are comparing with the proof of concept, no,
yes,
no, proof of work.
proof of work, work. Yes,
Proof of work is
yes,
what happens is the machine which has got the maximum computational power.
yes,
They
yes,
actually, there are thousands of machines getting into a race,
yes, yes.
and the thing is, the machine which has got the maximum computational power
Mm-hmm.
wins the race and cuts the
Yes,
block.
yes,
Okay,
yes.
that is proof of work. But
Mm-hmm.
here in Hyperledger Fabric, okay, uh, so for explaining that one, I have to explain the consensus, which actually
Yes.
we took out of scope for this one, but I will explain it now. In Hyperledger Fabric, when I told about orderer, I told that there are three types of orderer. One
Mm-hmm.
is solo, the other
Yes,
one is Kafka, and the other one is Raft.
right.
Raft is a consensus.
Yes, consensus algorithm. Correct.
Raft is a consensus algorithm,
Yes,
and it's a crash tolerance consensus algorithm,
yes.
right?
Fault tolerance. Correct.
Yeah, yeah. Proof of work is actually we are trying to solve the Byzantine fault tolerance issue there in proof of work, right?
Yes, yes.
Byzantine fault tolerance we are trying to solve in proof of work. But when in a permissioned network,
Mm-hmm.
when we are already validating our business rule with a smart contract, do I need to go for a Byzantine thing? Because already these I have told, these four nodes will check whether
Mm-hmm.
my business transaction is valid or not.
Yes.
Okay, I am authorizing those four nodes. It is just like a proof of authority, or so I'm authorizing these four nodes to make
Mm-hmm.
sure that, okay, the transaction which I am doing is correct or not. So once they run the smart contract and they validate, they confirm me back that, okay, the
Mm-hmm.
transaction which I am doing is correct, then I have to just order it. I have to just collect those transactions because it's already done. That means this
Validation is
particular,
done.
yeah, this particular business scenario is fulfilled. Now we are just collecting those transactions at the orderer using a raft consensus. Once 10
Mm-hmm.
transactions have reached, okay, we are cutting a block and sending it. But that is not applicable in case of public blockchain, where you cannot trust. Here we are trusting these
Yes.
authorities,
We
and
need to
the
perform
trust
that.
is mainly
Mm-hmm.
based on the smart contract, and the
Yes.
smart contract is actually agreed between all the 10 organizations.
Yes. Correct.
These 10 organizations agree to the smart contract and tell that, okay, these people need to execute it because that is their business rule. Port has their own business rule that has to be validated.
Yeah. Yes, sir. So can I ask one more question, please?
Yeah, sure, please go ahead.
So, may I know, is there anything called full node terminology existing in the Hyperledger, say, Fabric? And
uh,
say Hyperledger, I mean.
no, I didn't get your question. Full node means
Uh, so there are some nodes which are, when you install it, no?
mhm.
So some nodes are getting designated as, say, full node. And my query is still there. So how particular set of nodes, or how one, two, or three nodes are say getting designated as full node? And I read somewhere like full node is the concept where you identify the nodes to allow them to perform the consensus, and then say, for example, validate the block of transaction, and they'll be allowed to expand the chain and add the new transaction to the block. So again, the question was same, like how a particular node is identified as a full node. So if it is application based, then
No, it is, yeah, that's what. When it comes to the permissioned blockchain, it is all application based. The thing is, the architecture of each blockchain application in a permission blockchain is different. Example, Quorum. If you take Quorum is an application, is a blockchain which is built on Ethereum. Only thing
Yes.
is they have removed the proof of work concept from there and they have implemented Raft over there. Okay,
Yes.
and the thing is, so most of the transaction, the thing is like, okay, the public transaction. The thing, imagine, okay, okay, there is one more. There are many other concepts in Hyperledger Fabric. Okay, I have just glimpsed through these things. There is one more concept called private transactions. Okay, imagine I have a channel with all the 10 participants. Okay, and I am okay. Let us consider it is a blockchain of pharma industry. Okay, it's a blockchain of pharma industry. Each pharma industry is doing their own research. Okay, but they may be having a tie-up with another pharma industry. So they have come up with some other new innovation or like, okay, with something which they want to publish. Okay, they want to make a record that, okay, they have done it, but okay, they don't want the secret to be known to the other participants in the
Yes.
blockchain. Okay, so what happens is, okay, they can send a private transaction between them, these two, and store only the hash of the transaction in the public blockchain. That means for other participants, they will not see what the transaction is. They will just come to know that there is a transaction, private transaction happened between these two parties, and there is a hash. This is the hash of the transaction. So that later, if these two parties get into conflict, naturally there's a public hash which can show the proof of it. Got it? That's so each architecture is different. So
Yeah.
when it say full node, the public blockchain concept and the private blockchain concepts are entirely different. Is it clear, or like you have still
Yes.
more queries?
No, sir. No, sir. My doubt is clear. Thank you. Thank you very much, sir. Thank
On application. So the other question is, after ordering the transaction in a block, does the orderer sends the block to all the peers in the network or peers specific to the channel in which transaction is relevant? Absolutely brilliant question. Okay, the thing is, it is mainly channel based. The thing is, the ordering and the cutting of the transactions are happening only channel based. That is the difference between public blockchain and the private blockchain. They don't have to segregate everything. It's all one channel. What all, there is no concept of channel. We can imagine that there is a channel, and what all transaction comes, cut it, send it. But okay, health department transaction, that transaction should not go into a block of the PWD department channel, right? So the thing is, health department things will consolidate it, and it will be like put into a block which will go to the channel of the health department channel, and all the peers, yeah, all the peers attached to that channel will receive the block. Not every peer in the network. When a block comes to the channel, through channel it will reach the particular peer. What happens is, all the peers in that channel will receive, and there is another clause to it. Let me correct my statement. It is all the leader peers in the channel will get the block. Okay, from the order, all the leader peers of the channel will of the organization in the channel will get the block, and the leader peers will distribute this block to the other peers available in that channel. Okay, so blocks are channel based. Okay, now let's move to the because anyway I need to stop this session by around 4 o'clock. So what I will do, I will move to the uh, lab of this one. Okay. Lab means like, okay, I have a scenario, and let me just make my system up. I'm just remote desktoping to that one. Okay, hold on, share screen. Hold on 1 minute. Let me open the PPT also. Okay, can you see my screen?
Yes, sir.
Yes, sir.
Santosh sir.
Okay,
Yes, sir.
fine, good. Yeah, so let's take a business scenario, and let's take a business scenario, and we will just 1 minute. Let me log in here to my system, remote desktop. Yeah, fine. Let it be there. Now we will. Okay. So we will go through the use case. This is also a very simple use case, making you understand how exactly this is working. It's a logistic blockchain demo which I'm telling you. It is not a practical blockchain solution which I'm pointing out, just pointing out how I can implement the blockchain network in the simplest way. That's all. So here there are two members. Okay, one is the OEM, that is original equipment manufacturer, and a dealer. So imagine, let's consider Maruti Suzuki. So Maruti Suzuki builds car. Okay, in the blockchain world, car is an asset. Okay, and many things, like not only car, like, okay, even if you submit a purchase order, that is also an asset. Okay, that's a document. It's a, like, okay, the transaction is happening on the purchase, so that's also as an asset. So here we have Maruti Suzuki, or the OEM and the dealer. Okay, and we are trying to build the network between these two. The flow includes the below step. Okay, the requirement is like this. You can go through. The network consists of OEM and dealer. Okay, only two members. Okay, the dealer creates the purchase order, submits to the OEM. That means they are procuring for the cars. And the purchase order includes the information of the number of cars ordered, their model, make, and the color. Only the dealer will be allowed to create a purchase order. The OEM accepts the purchase order raised by the dealer and starts preparing the car as per request. Okay, so once the purchase order comes there, once OEM accepts the purchase order, they will start building the cars. And okay, after the cars are manufactured, OEM raises a sales order and assign the cars as per the purchase order requirement and delivers back to the dealer. So OEM sends a sales order to the dealer once he delivers the cars. So what the dealer does is, dealer accepts the sales order and generates the goods received note, GRN, and sends back to the OEM. That means they acknowledge it and they send it, the goods received GRN note. So after that, once OEM understands that, okay, knows that, okay, the dealer has received the goods, okay, OEM will generate the invoice. Okay, so only OEM can generate the invoice. Okay, and these are all just parameters which are limitations or constraints which I have given. The dealer accepts the invoice and check whether all items in the order, in purchase order, is delivered or not. Okay, and dealer will not make the payment of the invoice if the purchase order is not fully delivered. Okay, Before initiating an invoice payment, the dealer check whether the purchase order is fully delivered or not, and it will be processed if the purchase payment is only when the purchase order is fully delivered. Okay, so and once the payment is made, OEM acknowledges the payment. That is this is the business scenario. Now, who we have the concept of network operator, direct participants, and the indirect participants also. To make the stuff network simple, I have not included indirect participants. Okay, so we are dealing only with the direct participants here. So network operator, the network is operated by the OEM. The OEM is the Maruti Suzuki decides to build the network for them, for their dealers first. Then again, they may invite Hyundai or somebody like that. Now, this is the flow which I have told. The dealer generates the PO, OEM accepts the PO, OEM creates a car, and after that the sales order, and the sales order, and dealer generates the goods received note, and it updates a sales order. Once the all the goods are got, okay, the OEM generates the invoice, dealer checks full delivery of the PO. If it is not fully delivered, then holds the payment. If it is fully delivered, makes the payment, OEM acknowledges the payment, and dealer close the PO. So dealer created the PO and dealer is closing the PO. Okay, that is the scenario. We are just going to walk through the scenario. So this is a logical representation. OEM and dealer, purchase order, say sales order, GRN, invoice, and payment. Okay, so let's go here. So we are going to create three new terminals. So before that, now let's get into this one. So first, we are going to do this particular activity in 3 different steps. First of all, what we need to do, we need to build the network first. Okay, so how to build the network? So for that, it's a private permissioned network where all the participants are identified by the certificates. So what we need to do first, we have to generate the crypto material for that. And in my previous slide, I had shown that, okay, we have something called certificate authority, which Maruti Suzuki can have Fabric CA and Hyundai can have Symantec or any other CA. Okay, certificate authority. But here in our development environment, we are going to use a tool provided by Hyperledger Fabric, which is called Cryptogen. Okay, so in production, we cannot use that. We have to use certificate authority. And after that, okay, once the certificates are all created, who all are the members? Okay, first of all, I understand one more thing that, okay, we can start a network between 2 members, and later we can keep on adding the members into the network. Right now, we are not going to that particular extent. We are just creating the 2 certificates and we are just building the network between these 2. So after getting the certificates, we need to build the network. So for building the network, what we need a Genesis block. So I told you earlier that, okay, there is something I missed telling this when discussing the channel. When I told that there can be channel for PWD and health separately, there is some other channel which is not visible to anybody. It is the system channel. Hyperledger Fabric itself holds a system channel in the order. Okay, so when an orderer is the heart of the network, because the thing is orderer, once the orderer is down, okay, the whole, imagine if it is a solo order, if the orderer is down, you will not get the blocks. Nobody is there to order it and cut it. But if peers are down, 1 or 2 peers are down, yeah, still the network will run. So to build a network, first of all, what we need to build in a hyperledger fabric is we have to build the orderer. We have to bring up the orderer. And the orderer is like orderer requires a Genesis block, okay, to start with. So if you start an orderer without Genesis block, it will error out. Okay, all the configurations are provided through YAML. Host the orderer with the Genesis block and certificates. Okay, host the peers for member organization with respective certificates. Okay, generate a channel transaction, example, logistic channel. Okay, not actual. Okay. Now the thing is, now we, after building a network, okay, we are doing a logistic transaction here. This network is built for a logistic purpose. So I am just naming the channel as logistic channel, like that means health channel, PWD channel, the same way I'm naming it as logistic channel. Now let's go to the network setup demo. Okay. To identify just making this as network setup. This is the OEM setup. This is a dealer setup. So we will be doing all these three in a 3 different terminals for EC reading and just okay. Now let us go to the network setup. So OEM is not there, dealer is not there. We are going to start the network. So okay, this is all. So first of all, imagine that the network setup means we are trying to make the whole network up. Okay, so first what? Okay, so we are going to generate the crypto certificates for the orderer organization. Okay. Now the thing is, orderer we are considering as an organization, and that is mainly handled by OEM. That's what we are going to assume here. Okay, so the cryptos are getting created. Yes. So now if you see, the cryptos are generated for OEM and dealer. Okay, let me show you here. Under configuration, there is a crypto configuration. So here the cryptos are generated. The crypto is generated for the orderer organization and is for the dealer organization. Okay, so no, for the peer organization, dealer and OEM. Okay, so you can see many YAML files here. These are all the configuration YAML files. Okay, so I'm not getting deep into that one. It will actually just go over the head. So you can see the MSP over here. Even in the dealer also you can see MSP. Here in the OEM also you will be able to see the MSP. Okay, which will be holding the certificates. Okay, CS certificates and all, public keys and all. Okay, so we created this particular folder now. Now crypto is created. Then we are going to create a Genesis block. The network is not up yet. Okay, I am the admin. I am starting the network. I'm creating the network. So I'm creating the Genesis block. Genesis block is stored and bringing up the containers using Docker Composer. Now here what I am doing is I have built the Genesis block. Now I am going to bring up the orderer over the Genesis block, and along with the orderer, I am trying to bring up the peers for dealer and OEM also. Here the orderer orderer is coming up, and also the peers for OEM and the dealer. So just let's go bringing up the containers for using Docker Composer. So orderer is up. You see orderer.oem is up because it is associated with OEM. It is orderer.oem. So peer1 dealer.com, peer1 OEM.com is up. Now generate a channel transaction. This channel transaction is the logistics channel which I'm going to build. So what here I'm going to do is I'm going to build a transaction only. It's not a channel. I'm just going to build a transaction. I will tell you when exactly the actual channel will be implemented. I am just making a structure of the channel now. The channel should be like this, like that. So just gave the transaction, and transaction channel transaction is also stored. Okay, here you can see that orderer type is solo. Okay, and it will be using all the crypto related stuff. Now the network is up. That means network is up means the orderer is up and the peers are also up, but the peers are not part of the network. Understand the point here. Here the orderer is up and peers are also up, but peer is not part of the network. Okay, now we have to bring those peers part of the network. So let's see what is there. Docker peers. If you see, you can see around 3 Docker containers up. One is orderer and let's see, where is orderer, dealer peer, orderer peer. Okay, so I will close this particular stuff. I will close this network because my network is up, my peers are running. Now I will go to OEM. Now I am going to set up the OEM. So what we need to do for OEM setup? Okay. Now to make OEM join the network, what I need to do? First of all, I need to submit a channel transaction. Okay. This creates a logistic channel in the network. So just before, when ending the network configuration, I created a channel transaction. I will be using the channel transaction and I will create a channel. The channel will be created once when the peer submits the channel transaction towards the orderer for the very first time. So the OEM peer is going to take the channel transaction because it is there with me now. Okay, I am going to submit it and create a channel. Okay, so once after creating the channel, still I am not part of the channel. Okay, I gave the transaction to the orderer and told to create a channel, but I am still not part of the channel. I need to join the channel. Okay, so how I will join the channel is when I create a channel. First of all, now let's go back to the discussion which we had earlier in the previous session, in the previous slide. Okay, the previous slide means that Hyperledger Fabric architecture. I told that every peer can have multiple channels. Every peer can join multiple channels, and every channel will be having its own ledger. That means every peer can have multiple ledger. So that means if there is a ledger will be having a Genesis block. Okay, so when the peer submits a channel transaction to the orderer, a Genesis block for the channel is getting created. And the peer receives it back. Whoever creates the channel receives back the Genesis block. Okay, and using that Genesis block, the peer will join to the channel. And once it is in the channel, now the peer can install chain codes. Then after installing the chain code, it will instantiate the chain code. And after instantiating the chain code, it has to create wallets. You know what is wallet? Wallets holds the certificates, user certificate, end user certificates. Okay, so it will create the user wallets for the end users. Now let's go through this particular thing: submitting the transaction, joining the channel, and installing and instantiating the chain codes and creation of wallets. Let's go to the OEM setup. Okay. So the blockchain client of the original OEM will be hoster of this terminal. Okay, let's see. I just because anyway I have explained it in the slide. So now we have the channel transaction. We are going to submit it. Yeah. See, received block 0. Okay, and it is successfully submitted proposal to join channel. So first it received the block and joined the channel. Now we are going to see which all channels this particular peer has joined. List channel, channel listing, logistic channel. Sorry everybody, like I don't have a proper UI. I'm just showing it on the terminal because it's all like a crude thing which I'm just showing over the terminal. No beautiful UIs and all. Okay, and now the logistic channel is there, and what we are going to do is we are going to install the chain codes to the logistic channel, or to the OEM peer. Installation happens on the peer. Okay, so it is remotely installing a couple of contracts. Okay, that means one is a purchase order contract, the other one is a sales order contract, the other one is a GRM contract, the other is a invoice contract. So like that. So all these contracts are. So instantiate channel on the logistic channel. Instantiate chain code. That means it is now only the chain code is only there at the peer now. Now we are making the chain code logically available in the channel. Okay. Now we are making the chain code logically available in the channel. So what is the use? Why we are doing it? Because when other peers join this channel, they will have this particular instantiated chain codes available in the channel. Okay, you will understand when we do the next step for the dealer. Chain code insert, create identity for the OEM users. So we have created an admin user and we have created an OEM user one. Okay, so the OEM setup is also done. I'm closing this particular window also. Let's go back to the slide. Next, dealer setup. Okay, so how dealer is getting set up? Dealer setup is happening in such a way that, okay, first the channel is already existing, correct? So what this dealer has to do, dealer has to get the Genesis block of the channel. So channel is already having the Genesis, so the dealer will request for the Genesis block. Once it gets the Genesis block, it joins the channel using the Genesis block. Okay, then it installs the chain code on the peers and wallet is created. You can see one step missing here, that is instantiation of contracts. Instantiation, I told that it is like we are making the contracts available in the channel. by instantiating a contract on a channel, we are making it available on the channel. So the chain codes are already available in the channel, and this peer is going to join the channel. Then why do you have to instantiate it again? It's already available there. Only thing is that this particular peer need to have a copy of that. That's what we are doing in the install. Okay, so let's go and check that particular scenario. Dealer setup. Okay, let's make this one a little more big. Okay, so what I have told, okay, it's going to, dealer will fetch the Genesis block. See, received the Genesis block. Now, after fetching the Genesis block, dealer will use the Genesis block to join the logistic channel in the network. Continue. Yes, successfully submitted proposal to join channel. Join the channel. Now we are going to see which all channel the dealer has joined. Yes, it has joined the logistic channel. So now installation of chain code. So all the 5 chain codes are getting installed here. Then no need of instantiating. We are just straight away going and creating the identity for the users who are going to submit the transaction into this network. Okay. So we have created the admin user, and we have created the admin users for both OEM and dealer. Okay. Now we'll go to our demo here. So dealer, this is a dealer application, and this is an OEM application. So friends, what you have to first of all imagine is like what we have shown you, the dealer prompt, the OEM prompt. They are supposed to be different remote machines. Here I am showing it in one setup, in one my machine. Actually, dealer setup is happening somewhere else, maybe here at my desk, and the OEM setup and the order setup happen at Delhi, Gurgaon, if it is Maruti Suzuki. Okay, so that's a concept which we have to build here. Like we have to imagine in that way. Okay, now I am going to create 2 applications. So let's in our picture we have put OEM here and dealer here. So okay, so let's keep that one. So we will keep this guy as a dealer. So dealer app from dealer organization, and so OEM app from OEM organization. Okay, and we need to get into this folder where the program resides. Okay, so now first of all, dealer submits a purchase order. Okay, I am going to run the dealer app is going to run. Okay, let's clear this. So dealer app is going to submit. So now dealer node is ready, and we are going to submit a purchase order to OEM. Continue. Yes, few cars. For some reasons, okay, actually it should have shown. Actually, I modified my program in the morning, and okay, so the okay, so the dealer has submitted the purchase order, I mentioned the purchase order as PO ID 1, and the PO status is created. Okay. And the next step is OEM must accept the PO. Actually, like I was having it displayed, but I don't know. I don't know whether it will work now or not. Let me see. Yes, actually, I was supposed to print it here once, but okay, somehow I missed that code while beautifying it in the morning for making it convenient for you guys. I missed the primary step. Okay, actually, like we should have printed here. Now, what happened is OEM accepts the PO. Now, let's go to a new window, new file. Okay, new file, paste. Okay, I'm sorry. Don't save garage one. See, this is my purchase order, which I have submitted. Okay, these are the orders. So order number, order two, order number. That means order serial number. This purchase order has got multiple line numbers. So 1, 2, 3. So it's Maruti Swift. I'm ordering 5 blue Swift and 3 black Swift, green Swift 2, Baleno, white Baleno 5, and brown Baleno 4, like that. That is my this purchase order. Now here, if you see, there is something called sales order, there's something called GRN, there is something called invoice, and all delivered. So these are the flags which we are trying to see. Now what? Now let me again come back to you guys. Okay, let me make you understand this a little more clear. These two are two different organizations. This is Maruti Suzuki. This is a TVS Sundaram dealer in Kerala. Okay. Now, they don't have a physical network connection. That means they are not hosting the same application where, okay, like I submit something and I am able to see it like Tally or PeopleSoft or Oracle or like Workday. They are not running a same application. Okay, most of the organization, you can imagine in colleges and all, your college will be having an application, and in every department you will be having a department window, or like you will be having a department's subdivision, and you will be having some forms over there. But if it's in the same application, it is referring to the same database. It's a centralized database. Now these two are two different organizations. Now, what happened was dealer so dealer and OEM are only connected to a blockchain network. They don't have a physical one-to-one direct connection. They are just members of the blockchain network. Now what happens? Dealer submitted the transaction to the blockchain network. That's all. Dealer didn't insert anything to the database of OEM. What OEM is doing, OEM gets that particular data from the blockchain. So dealer can never say, now it's on the blockchain. The dealer can never say, go and say that, okay, I never ordered these things. Because it's there in the blockchain. Now OEM picks from there. Now OEM, what happens here, we can see that OEM accepts the PO and create the car assets as per the order. So this is the purchase order. Purchase order is received, and then OEM creates a car assets. Just I have given some vehicle IDs, and I have created assets. Vehicle ID 1, vehicle ID 2, 3, and all are same. See, I ordered for 5 blue Swift. So see, 5 blue Swift. 4 black Swift, like that. All these things are getting, assets are getting generated. So the PO status is now marked to in progress. Okay. Now what next? The OEM generates the sales order. Okay. Now OEM generates the sales order. That means they have created the cars. Now they are sending the cars to the dealer along with the sales order. Yes. Okay. Now there is something wrong which has gone on. Actually, I should be getting all this particular things. I'm not getting it. Okay, whatever it may be. Let's see. I will show you in the next step. I will show you. So next step, dealer must accept the sales order and generate a GRN. So the sales order is OEM has generated the sales order and it has sent it to the dealer. That means the OEM has generated the sales order. It has pushed into the blockchain. Now the dealer must accept the sales order and create a GRN. That means dealer should accept it and create a good receive note. So here in the dealer network, what happens is dealer accepts the sales order and creates a goods received. And the network system is extremely slow. You see, I will take this particular JSON file and I will just explain you what has happened here. You just actually you should have seen it. You should have received another JSON here in this terminal. It didn't come. So the order remains the same. Okay, order, this is the order remains the same. Okay, now there is a sales order entry which is entered, updated in the blockchain. Now this is the state of the purchase order asset in the blockchain. Okay, when I showed you the previous JSON, this one, when the dealer submitted the purchase order to the blockchain network, this was the state of the blockchain network, and this is the state which the world state will hold, the latest updated state of that particular asset. This is a PO asset. In that world state, the sales order was not there, the GRN was not there, goods received note was there, not there. Now the updated state is here. We have a sales order generated by the OEM and there is a GRN generated by the OEM. This is the world state. And all other previous transactions will be there in the transaction log ledger as blocks. I hope you people are understanding. So these are the two different things. I told you Hyperledger has got ledger, two different ledgers. One is the world state, the other one is a transaction log. Now this will be there in the world state, and all of the previous transactions along with this one will be there in the transaction log. Now next step, sales order and generate GRN. Now next, OEM must accept the GRN and create an invoice. OEM will accept the GRN and create the invoice. So invoice is created. Okay. See, I wanted something like this before also, earlier also, but okay, somehow while cleaning the code, I would have commented that statement. Now you see invoice. Okay, you can see here invoice 1. I can show you here. See, this sales order is 1, GRN is 1, invoice is 1, and this will be the current world state of this asset for the PO1 asset. I am telling the asset name is PO1. Okay, now invoice is also updated here. Now next step, dealer must accept the invoice and do the payment. Oh, dealer accepts the invoice. Okay, till now you can see that it is PO in progress. Okay, now dealer pays the invoice. Okay, now okay, there is another logic which I have incorporated, but okay, due to lack of time, we are not going into it. If it is partially paid, no, you will not. He will not pay the invoice. He will check whether. That's why we have this flag over here, whether it is all delivered or not. Okay. Now, OEM dealer pays the invoice. Excuse me. And it is paid. Okay, invoice is paid. See, the payment is initiated. The PO status till now was in progress. Now the PO status, it is the payment initiated. Okay, this is the world state current status. The payment is initiated. Now the OEM must acknowledge the invoice of the payment. QE OEM marks the payment received. Okay, now payment received. Okay, dealer must close the invoice. Dealer is closing the invoice. Invoice PO is closed because the dealer created the PO and dealer is closing the PO. It's not like okay, every document need to be closed. Yeah, this business requirement is like this, and it is happening like that. So this is the crude form of demonstrating the stuff. Okay, and all these things are achieved through many. All these configurations are achieved through many YAML files because there is core.yaml and like there are many crypto config transaction YAML. These are the YAML files which will be deciding what will be how the network will be behaving. With these YAML files, we configure the network. So hope you understood like okay how exactly this Hyperledger fabric can be implemented in the simplest form. We created a channel and we did a transaction. We did not only one transaction, we did multiple transactions. The transactions were such a way that okay, we were updating the status of the PO asset, also sales order asset, good received note asset, invoice asset, and payment assets all were getting created. We had created multiple assets there, that means documents there, which we stored in the blockchain, but okay, I didn't display those things. I just showed you how the status of the purchase order document was changing. Okay, and all this transaction happened because the thing is, what I want to tell you again is there is no backend database here. It is only happening on blockchain. There is no separate database. And that too, blockchain is using the default level DB database for the blockchain network. The OEM application is not storing anything in its own database and interacting with blockchain. No, interacting with the dealer. No, there is no. There are only two terminals which is representing the application, and it is interacting only to the blockchain. And all this transaction which you have seen is coming from the blockchain. Okay, any queries? Anything? So that actually like okay comes, oh yeah, we are 3:53, we are almost near to 4. So any questions, anybody? If you have any questions, you can ask me directly, or you can, whatever we saw in that slides, earlier slides, we demonstrated it actually. Yeah, but there are many more things. So if you have questions, I can take it.
Hello, Santosh sir. Can you hear me?
Yes, yes, I can hear you.
Sir, actually, I have one doubt. The thing is that you did this demonstration using a single system, right?
Yes, I did this using a single system.
So my question is, if I want to create this application in a multi-node way, like different systems and different roles are accessing multiple systems. So in that scenario, what will be the challenges? I mean, I want to know the technical challenges if you are using multiple nodes instead of a single one.
Yeah, the thing is that particular thing, okay, your peer is config. I told one thing that many of the nodes over here, orderer node, the peer nodes, all are configured using YAMLs. Okay, so
Okay.
the thing is the orderer node here, the orderer node port number is my Docker port. Okay,
Okay.
and the peer node ports are also my Docker ports. So in that case, when you are hosting in a different network, naturally this configuration YAML file will be having different IP addresses and ports which we are hosting. And there are some configuration files which will be used for the client applications. The client application, what happens, your mobile application, if it has to connect through the peer, there is a connection profile. Okay, there is a connection profile which will be used to connect to the peer, and the peer will be sending this SDK will work on behalf of everything. So what we will do is you will give all this IP address configurations and all this port configuration in those YAML files, configuration.yaml file and core.yaml file, configstx.yaml file. There are multiple YAML files for each component. Okay,
Okay.
orderer there is a YAML file, certificate authority there is a YAML file. So everything is configured using YAML, and it is only the play of configuration to expand it. Now I will put a different scenario in front of you. There is a concept called network of networks.
Okay.
Okay, network of networks. I talked to you from a point of blockchain implemented in Kerala. Now imagine every state in India implements a blockchain in their own network. So if all the Grama Panchayat of every state tries to connect to the blockchain, will it be feasible? No, it will not be feasible. So you will be having a separate network for the all over India, which connects all the states, and there can be 2 or 3 nodes from each state participating in this network. So what happens, like we are trying to attach this state-wise network to a bigger network. Okay, that is called network of networks. Okay, there are all different network for each state, and which is getting attached to a bigger network for whole over India. And here what happens, each state, each Grama Panchayat may have its own peer, and the IP address and the port number for those peers will be unique, and that will be configured in their core.yaml. And what they will be doing, these people's like okay, actually like okay, these peers join to the channels. Then like that, when they join to the channels, all other peers in the channel will come to know, yeah, okay, this particular person has joined this channel. You are not going to propagate to anybody physically that, okay, I am here. Like, you join the channel and everybody else in the channel, all other peers in the channel will come to know that you have joined the channel. So every configuration is done using these files. You just dig into these files. One is config.ts.yaml. The other one is core.yaml. Core.yaml is used for peer configuration. Config.ts is mainly for order configuration. So you just understand this, and the connection parameters are there. These three files, if you try to understand, you will get it. You'll find these ports there.
Okay, sir. Thank you. Thank you.
And if you are trying to virtualize it, on your machine, and if you have enough RAM, you make 2 virtual machines up and put it on a bridge network. Don't use NAT. Use a bridge. On a virtual box, you use a bridge network, and you'll have 2 different IPs, and you can physically do that. And if you can connect to 2 different virtual machines, yeah, you can connect to a number of other machines. And if you want to install Hyperledger Fabric, just go to the Hyperledger, just type Hyperledger Fabric documentation. It will take you to the documentation of Hyperledger Fabric. There you have a separate section in the documentation for installing. There they will give you the latest versions of dependencies. You have to follow that one. For each version, there is a dependency. You have to follow that.
Docker and all we have to need to install, sir. We need to install Docker.
Docker is part
Docker
of the dependency. Docker is part of the
Oh.
dependency. So first of all, to write and
Oh.
execute the program which I have done now, you have to install the Hyperledger Fabric framework on your system. Okay, so for installing the framework on your system, you have to follow you have to install some prerequisites. Some dependencies are there. All those dependencies are version dependent. Okay, for 2.1 there will be some requirement. For 1.4 there will be another requirement. So whichever you are installing, you go to the documentation page. There they would have mentioned what all are the requirement, what all are the dependency. Follow that one, and you will be successful in installing the stuff. And you have even sample chain codes which you can install. You can try it out. I always recommend you guys to think over the scenario which I told of that state government. You can just put it on a paper, and you will be able to understand a lot. Okay, yeah, fine. So any more
one
questions?
more doubt, sir.
Yeah.
Sir, one more question, sir. It can be run in Windows mode or Linux mode, sir. Which operating system will support for this?
It is mainly Linux.
Hybrid.
Ubuntu. Mainly Hyperledger Fabric.
Oh, it won't support for.
In Windows, you can host a virtual box or virtual VMware, like, okay, whatever it may be. You can install a hypervisor, and you can host a virtual machine on that one, Ubuntu virtual machine, and you can do it. Anything more? Anybody?
Hello. The
Yeah.
participants, if you have any doubts, please ask right now. So I think almost all queries are over.
Yeah, fine. So thank you very much.
Okay.
Santosh, sir.
Yeah.
Thank you.
Thank you. You're welcome. Thanks everybody for patiently attending the training and listening to me. Okay.
So it was a very fruitful session for many of the participants. And presently we are having 79 participants just remaining. And I think many of them have been getting a good idea on the hands-on practical side of the Hyperledger Fabric. And thank you for supporting all of us all throughout the way. And thankfully acknowledging Santosh Thomas. Mr. Santosh Thomas is consistently supporting the Club-Saintgits blockchain team for the past few years, and sincerely thanking for all your supports.
You're welcome, sir. Okay. So,
One more, a word of thanks from Sijo sir, please.
Thank you so much, Sanjay sir, for providing a right mix of fundamentals and technology behind a blockchain with a focus on Hyperledger Fabric and the demonstration OEM, which I'm pretty sure that participants got a solid foundation from where they can launch their journey in the world of blockchain. Thank you so much for spending your time with us, sir. Thank you.
thank you very much. Thanks, everybody. So, wish you all the best in the blockchain world. Okay. Hope we will be able to connect later in this blockchain world. Okay. So, good luck. Thank you. Okay, I will just sign off now. Okay.
Dear participants, you have one note. A bunch of technical sessions are waiting for you tomorrow. We will be having our validatory function at 3:30 p.m. tomorrow, and the test will be conducted, and certificates will be issued to only those participants who successfully qualify with a minimum 60% in the test. Thank you. For the kind attention of the participants, you are kindly requested to fill in the feedback form, which is available in the chat. Thanks once again. Have a nice day.